Hello and welcome to the Time for AI podcast, the podcast that brings you the best conference speakers and allows them to sum up their presentation in 5 minutes. My name is Peter and I'll be the host of the podcast as I've been in the previous episodes. And if you're interested in everything that is happening on in the AI field today, I would encourage you to go and check out the previous episodes. We had some great speakers talk about all of the new things happening in AI. And of course, if you want to do one thing for the beginning of the new year, just tell a friend about this podcast and I'll bring you more of the best AI conference speakers in the next episodes. Today, we have a great episode in front of us. With us, we have Grigorij. Grigorij, hello and welcome to the podcast.
Well, Peter, it's nice to be here.
It's great to have you here. Grigorij, you are the team leader of RoboCrew. Can you tell me what is the company, what do you do, and what are the things that you do there in the company?
Yes. So what we're doing is we are doing an intelligent robotic algorithms to make robots, especially that humanoid-like robots, household robots, but not only them, actually almost all the mobile robots, to be intelligent and self-conscious. It means we want our robots to be able to make decisions by itself, not to be controlled by a human, for example, but make like own decisions. And we actually trying to achieve it through providing an LLM agent to the robot. How exactly we're doing it, I will tell you a little bit later. But the core idea here is to provide an LLM agent, which the same way as you, for example, have LLM agent that make an internet research that can I don't know, check weather on another city, read some sites, and sum up different information it found using like special tools. Can also like run the robot and control robot also like with that. So the single difference here is that we have the agent in the real body.
All right. We'll talk a bit more about that later. What you're the team leader there? What does that mean? What do you do on a daily basis, and what is your favorite thing that you do there?
What I'm doing daily basis, like organizing team, creating that robotic control algorithms, and ton of stuff. So actually, I'm very like to do it because it's like the cutting edge. What we're doing is the thing that nobody before us done, and uh, yes, actually, mm, it's yes, actually creating that algorithms. I will share more details a little later.
Mm.
And yes, and
Mm.
organizing people, which is actually is even more complicated tasks than working with robots.
Okay.
So yes.
One of the things that I was impressed with when I'm looking at everything about you, you have a project on GitHub that is called the Clean Coder. Can you tell me a bit more about what that is and who should go and check it out?
hmm yes, Clean Coder is my previous project. It's not related to the robots. It's the application, uh, also AI agent for the coding. So it's AI coder actually, which I've been developing for some 1 year ago, which is quite advanced. At some point, been one of the most intelligent AI coders from all available. Yes, so it's agentic system that analyzes the files on our project, um, thinks how to write the best code, how to fulfill the task, uses appropriate tools to write the code, to check that code, run the tests, and like run its code it written, and so on. So yes, the currently obviously it's not so big boom for AI coders. It's been big boom for AI coders like 1 year ago or 1.5 when I actually been doing it. Yes, so at the moment when I've been doing it, it's been the cutting edge technology. And
Okay.
yes, for now it's like quite normal thing I think today, because nowadays everyone, like not no many of us using AI for coding, and such projects as Clean Coder, for example, can support us in that AI coding. So like for that of our listeners who are programmers who want to speed up their programming, especially when we're talking about some web applications. Such clean coder could be really useful.
Okay. We'll add the link to the project in the show notes and people can go and check it out. Grigorij, I've invited you to the podcast because you had a great presentation at the RPA Europe conference, also called the AI Summit conference, a conference with two names. We're actually both speakers there. We'll get to your presentations. Was this your first time at the conference and how did you enjoy it?
Definitely not my first time in the conference, but yes, maybe yes, it's the first time during last when it been? It been in November, so for last like few months, I think it been
Okay.
first time, because like for
Was this the
end
first
of
time
the
of this conference of the RPA
yes, first
Europe, or you've
definitely
been there for? Oh, okay.
yes, definitely first time in Lithuania when I have like conference in Lithuania. Yes, and one of the first times, not the first time, but one of the first time when I'm presenting with the topic of the intelligent robots, which is quite new topic for me, because I also doing the topic only for half of the year. And yes, and it's like really cutting edge technology that is very fresh, and that one that's actually the point when you're doing like very new technologies. So you also like switching the topics quite fast, and need to be able to just learn very fast new things.
Mm. Okay. All right. Let's go to your presentation. The title of your presentation was How We Created a Thinking Robot. Grigorij, here are your 5 minutes to sum up your presentation.
Yes, thank you, Peter. Uh, so. mm, So as I said before, we're working now on implementing the LM agents inside of the mobile robots in order to make that robots autonomous and be able to work by itself without human control, without human help, but just to have that robot that, for example, work at your home, at your kitchen, whatever, and cleans your home. Go into different rooms, gather different, let's say, papers or other trash you have in the home, and uh, and throw in the trash out. The robot that can go to kitchen and make some breakfast for you, for example, or or bake a coffee, uh, and so on. So a robot that is completely by itself can make decisions. What he need to actually do, where to go, which room, which how to grab appropriate things, in order to make that um, to execute his task, which could be like home cleaning, but could be anything we want. In order to do this, we're using the LLM agent. Mm, and we equipping the LM agent with tools. But in difference to the normal LM agents, when we have like just out of the and another side of the monitor LM agents, which can check weather, book flights, and so on, that agent can call tools like go move robot forward, turn that robot, uh, or call another AI as a tools in order to control robot arms. Uh, so a little step back here, the robotic platform on which we're working on is so-called XLA robot. So it's quite imitation, the substitute of the humanoid robot that I will said. So it's the mobile robot on the wheels that have two robotic arms. So in fact, that robot can go through our house, also grab the different things with his arms, make cleaning, make a whole bunch of different things humanoid robot also can do. So yes, so here we provided the LM agent for controlling that robot, controlling his movement, and using a VLA models. It's so-called VLA or Vision Action Models are the models that used to move the arms of the robots. Because as you can imagine, for example, to just move robot, it's just easy to move robot because in order to move robot forward, you need to just rotate two servos and robot moves. But in order to grab a piece of paper from the table, you need to move all the 6 servos in the arm of the robot, and you just can calculate with LLM all the positions of the servos in order to grab that paper. So that's why we use the VLA models that are able to do so. And most important thing here that we use VLA models as a tool of the LLMs. So here the one AI is a tool of another AI. Yes, and sip of water. So one of the most interesting things here is the biggest challenge in the robotics right now. The biggest challenge in the robotics called generalization. Or when we want to make our robot to do something new, to make task without pre-training a robot for doing that concrete task in that concrete environment. So, for example, when we placing the robot in your house and asking the robot to go to kitchen and make you breakfast, that robot should be able to do it without even knowing how does your house looking like, where is the kitchen is, how to make that breakfast, where you have plates, and so on. And most of the robotic community imagines that in order to achieve that generalization, we need just to train a big VLA model that will be able to control all the joints of our robot and will be able to do all the different tasks that our robot can do, to move the robot, to make the breakfast, to move his arms, and so on. And yes, in my opinion, the most of the robotic community is wrong here. In my opinion, we can't for now and for near future do something like that, because the VLA models is the not models intended to think. It's the not models. It's the models that are able to control your arm, that able to, for example, grab something or whatever, but they are not able to reason. Then, in order to make something more complicated, in order to make the task that includes few steps, we need our model to be able, our AI inside the robot to be able to think, to be able to plan, to be able to be conscious. And then, after making that high level reasoning, our robot should make low level tasks, like grabbing cups or going to the kitchen. So that's why I think the road to generalization is not through the just single VLA model, but through constellation of different models and automations, where in the very middle of it, we have LLM that just make the big generalized thinking and code the tools like going forward, turning, grabbing things, and so on, activating VLA policies, different VLA policies for different manual tasks. Also, we obviously need to support that LLM by providing good quality input data. By input data, I mean the input from camera sensors, where we need to not just provide the raw camera image to LLM every time, but we need to augment it. So For example, what we do in our robot, we provide in the top of the camera image the angle of the grid of the angles that help robot to turn more precisely. So, for example, if our robot sees that the doors to the kitchen is somewhere right, but he not actually don't know by raw image to which angle he need to turn in order to go to the kitchen. But when we provide the grid angle on the image, he already know that okay, that kitchen is the 20 degrees right. And yes, that way we support in that robot. Yes. Also, there's some bunch of other ways to provide input data. For example, to add LiDAR sensor, what we're doing now, to add the microphone and be able to speak to the robot to give him a tasks, and yes, and we even can add also speaker to the robot and be able to speak with the robot, and so on.
Right.
So it's bunch of different things we can do with robot. But the core idea that we're doing that skeleton AI, that constellation of AI tools, models, and automations that make our robot conscious and be able to do a whole bunch of different tasks by itself.
All right. Excellent. That sounds great. A couple of questions. Your robot is it using is it processing everything on the robot, or is it using an link to an API to large language models somewhere else? Or are you doing everything on-prem on the robot?
Currently, the robot uses actually API. We're using the Gemini to process it. I find that the Gemini model is just best for robotic application.
Okay.
But also, we can easily run that models on the locally on the robot. I mean, the RoboCrew framework by itself allows to run them on the robot, but the single thing we need to do in order to do this is to provide the robot itself with appropriate hardware. It
Mm.
means we need to exchange the Raspberry Pi, which controls our robot now, to something more powerful. For example, the some NVIDIA Jetson devices, which has like graphical cards on the edge device inside.
Okay. Okay. Excellent. In the field of self-driving cars, it seems to be it seems that there is still a big question out there about lidars versus cameras, right? Which of these are more useful? Which of these are more specific when seeing stuff? You are using both of them on the robots, if I understood you correctly. Can you talk a bit about the comparison of these two, and how did you get to, and what's your opinion on the question?
Yes. So we're using both of them. I mean, currently, mostly we're using the camera only, and camera only is completely enough for our application to make
Mm-hmm.
our robot like working home. But LiDAR will be complementary sensor. So when we have camera, the pros of the camera that just robot is able to see straight forward and like, just understand the environment. Camera is just needed to be here. But problem is camera that cameras like has its own perspective, its angle of view, and not sees what's behind of the robot, for example, not sees what down of the robot. So obviously we can add here more cameras than one. It could be one of the solution, but still not perfect. And one of the solution could be LiDAR, which is just work 360 degrees, can see all the walls around. Yes, and using LiDAR, we can just have top-down map of the obstacles around of the robot
Mm.
without any that perspective occlusion and other problems, and so on. So yes, but here I'm talking about our use case. Definitely with cars, self-driving cars is totally something different because in self-driving cars it's not about the intelligence itself; it's more about robustness and safety. So yes, we're doing like something less. Self-driving cars they are not like conscious actually. They just need to go from point A to point B, and that's all. It's just simple if-else loop and nothing special. But we're doing something that will be less robust, but more intelligent.
Okay. You said you're using Gemini to analyze the images that you're sending and do the decision making. How did you get to that decision?
Well, the same way actually as LLM works and do the decisions in any other agent, as for example
Okay.
in the clean coder, it's yes. So, for example, in my previous project, clean coder, our agent also need to make decision in order to which like piece of code to write where and so on. But in the case of clean coder, he really need to think, like analyze the code, make the best decision. It's complicated. In case of robot, the decisions they much easier actually. It's just decision to go forward, to turn right, left, to grab a cup or whatever. It's not something that requires thinking. The bigger problem here is not the actual intelligence of the models, but the
Mhm.
that lack of the physical sense in the models. Currently, LLMs are not actually trained to control a robot. They're not trained to have that spatial understanding. That's actually why we're using the Gemini models. They are from all the most popular models, they're actually best in that spatial understanding, and I think the Google quite trains them for that. Um, yes, so yes, not sure if
Okay.
I
This
answered
is
the
why that.
question.
Yeah, you did. You did. This is the reason why you're using Gemini. Okay,
Yeah.
so what's the future for your robots? What are the things that you're working currently on, or what are the things that you're going to do in the next month? Where do you see yourself going as a company?
Yes. So currently we assembling all the pieces of the like AI algorithm together. So we before we done our robot to like just to write. After that, we have that added the tools to activate to manipulate arms, grab objects, and so on. That we lay as a policy. We lay policies as the tools of the LLM. After that, we realized that actually both of the pieces work by itself, but they not work together. So, for example, if our robot wants to grab a cup from the table, and his navigation abilities be not so perfect, so he's going in the direction of the cup, but he's not going like precisely to that cup and activates the tool to grab the cup or too early when it's just too far from the cup, or too close, or by the when it's handled by the wrong angle, and so on. So and we need to make that bridge to make the both of the thing work together. So for example, one of the things we're working is the making the agent navigation more precise. So in order to do this, we introduced like precise navigation mode, uh, which is allowing the robot to turn his camera by different angle to see his body, to see obstacles around him, not to be able to see far away, but to able to see like close. And in that
Mhm.
mode, he makes only small movement and like that precise movement to precisely approach that cup. Yes, another thing we're doing now we improving that inference of the VLA model by itself. There's still problems in that client server architecture because for more advanced VLA models we need to run the model itself in some external server and on the robot only to run inference. But here's a problem: the software we're using, the underlying libraries, they has just badly created that client-server architecture, and we need to write it by ourselves. And what else? And also, like as for now, we have already quite some successes in implemented that bridge between all the functionalities. For example, we already done like all sequence when our robot have a task to grab a notebook from the table and give that notebook to human. So in order to do this, robot first approaches the table with notebook, next grabs that notebook with VLA policy, next finds and approaches the human in the room, and next gives that notebook to the human. And there is the thing that our robot already did, but that we already did, maybe not perfectly, not like for first try all the time, but it's already able to do it. And what we do now is streamlining. We want our robot to teach him to grab trash from our room, to grab different like papers from the table and be able to trash them out. So do something like really useful for everyday life.
All right, that sounds very interesting. And I really hope we're getting humanoid robots in our houses very soon, because the pile of laundry in my bathroom says I need a robot, right? We really need help.
Totally
Grigorij,
understand
thank you
it.
very much. Yeah. What are your future plans? Do you have future conferences organized? And where can people find you if they want to talk to you about robots using LLMs?
Yes, so my future plan, my future conferences. For sure, I will be a mentor on the hackathon here in Poland at 11th of April at its Civil 42 hackathon about civil defense and some dual use applications. And so yes, I will be like here mentoring. About some other conferences, we'll see. Like currently, I'm mostly concentrated on the work itself, not on the going in to
Okay.
conferences.
Okay.
But yes, but maybe when at the late summer or autumn, I will go to some conferences. But yes, for now, I just need to go deep dive to work. So where people can
Okay.
find me, you can see, check my LinkedIn, Grigorij Dudnik. Also, like if you're very interested in the LM agents for robots, you can check out our code, RoboCrew, because it's like completely open source code, and you can just run it in your own robot. Just find RoboCrew in the GitHub. And yes, and also I have a YouTube channel when I'm sharing that also our ideas about robots. We're showing our progress and trying to teach about the VLA models, LM on the robots and so on. The channel called Greg's Tech. So yes, also welcome.
All right. Well, add all of the links to the show notes of the podcast. Grigorij, thank you very much for being on the podcast. And you just go back to working on your robot. My pile of clothes is waiting. Thank you and have a great day.
Thank you, Peter.